Why do we see numbers in space? It's easy to have first ideas about this. For example, you can have a number system with 1, 2, 3, and then when you see a ruler next to another ruler next to another ruler in this space that you experience, that you perceive, you find a similarity between what you see in the number system, and so you can see the number system in space. But it's still interesting that what is experienced, what is perceived, navigable, is something that reflects a number system. And when you go further and you say there's a unit that is exactly the unit, and then I go twice the unit, it's sort of very precise way to define geometry, not with the approximation of having a ruler in front of you. You still have the sense that the space that you're talking about inherit properties of your subjective space. You can measure it, you can find that there's an extent to it. You can imagine that you navigate on that very precise subjective space. And as the model of numbers get more complex, when you go from the natural numbers 1 to 3, the rational numbers 1/2, 2/3, and so on, even to the real numbers, when you complete the number line, you have a very complex number system, and you still have the navigability of it. You still have this subjective space tied to it, which begs the question, how come these qualia, this thing that is proper to man to perceive space, of course, like inanimate object and other sensible object, will not perceive space as we perceive space? So there's like a qualia, a very subjective personal experience of space, and this qualia maps to a very abstract definition of a number, almost a real number lines with very precise relationships between the different numbers that are described. And it's a situation that is sort of accepted in the background, where we know we define numbers maybe as sets, and there's axioms, and then there's a construction of sets that match the axiom, and so we say these are numbers. And then we know there are tools that are more intuitive with the real number line that we may use when we apply some reasoning in analysis or other areas of mathematics or physics. So we map this abstract object to space, and it's sort of something that is not conceived with a lot of precision. We just assume that the way we talk precisely about this space is through these sets, through these objects, with a logical relationship that exists within the subjective space. But it remains that the subjective space is here. It is, you can go through it. You can imagine walking from 0 to pi. Is it longer than 0 to 3? Yes. There's a lot of things that get preserved. And I think one of the way to solve that is to conceive of this qualia, to go a step further and make the hypostasis of subjective space, conceiving it as something real. There is a navigable space built out of the same matter that is building our subjective perception, that has the exact structures of numbers. And when you go into that direction, you have a space that is totally subjective and totally well structured. And what you have when you have approximate versions of that space, whether when you perceive some approximate real number line on a board, or when you think about it, you have the shadow of this subjective space, but it still keeps the nature of being made of this subjective space that we experience ourselves in our experience. And I think that's an important concept to understand, that the work that we're doing with the mathematical trinity is using this fact that we apostatize space, subjective space, as something that exists, that is very well defined, well structured. And so when we talk about the unit, when we talk about the origin 0, when we talk about plus infinity, these are things that are defined in a very special material that is proper to, let's say, human cognition, that is not something that is accessible by a being with less self-modeling, and something that really is the very structured material of perception that becomes the source of the shadow that we see when we see numbers around us. And I've released a couple of animations, so I want to remind the goal of the mathematical trinity is to define real numbers in a different way, in a way that is very simple. And I'll just showcase quickly here. I'll make a further commentary of the spatial aspect, but first you have 0, 1 plus infinity, and with that you have the natural numbers by adding the extension of 1 to itself. Then you have each numbers is a scaling from the unit, and the unit ensures the inverse. So when you have 2, you also have 1/2. When you have 3, you also have the inverse scaling, and so you have 1/3. And then again, this 1/3 gets added to itself by the additive closure of infinity. And so you have, by the intervention of these 3 constants, geometrical, you have the rational numbers, all the ratios, p over q with p and q integers. And then once you have that, you have the final step for the real numbers, which is to have the fact that infinity is the only transcendent supremum, meaning all the supremum that you can define of series within the number system, if they do not diverge to infinity, they are part of the number system itself. They belong to the extension, and so they inherit all the properties of it. And so when you have the Leibniz series converging to pi, it is actually pointing to a number, the supremum of that, so it becomes pi, and pi has all the properties algebraic. You can add it, you can multiply it as the other numbers. And with these 3 steps, you have the logic of the complete ordered field that is defined, and you also have the geometry. You can conceive that as the hypostatized subjective space, with 0, 1, and plus infinity being particular primary numbers constant that generate the real number system, and they are in this subjective space, and then all the numbers that we see that are spatial, they become the shadow of this very well-defined subjective space. And to remind as well of this plus infinity, it's not a mystery. How you can see infinity is you take the plane, you have 0 and 1 here, and we contract the plane, we contract it to notice where infinity is, and so we use a contraction of the plane with a polar contraction where all the radius get contracted, and you see plus infinity at the end of the line here at 0.2 with the regular line, but since we contracted it, it becomes plus infinity. And this is the point. It is a point as concrete as 0 and 1, but it gets projected back, and we point to it with an arrow. But these are 3 constant, 3 geometrically defined constant in this hypostatized subjective space that are the seed for the number system, where 0 brings the addition, plus infinity brings the closure of the addition, and so you have some explanations. For example, why does 1 adds itself to itself? Why does it go to 2 and 3 and then so forth up to infinity, let's say? Because plus infinity is defined in such a way that it is defined based on the divergence theory. And so we assign to plus infinity the closure of addition, because the closure of addition doesn't point to 1, doesn't point to 0. They don't need the closure of addition. They point to something else. They point to plus infinity, which is a number to which the closure of addition belongs. And so why you have 1 plus 1 is because when plus infinity emerge, you need this closure of addition. So that's why it becomes part of the system. It's an explanation of how the number system emerge through three constants, 0, 1, and plus infinity, instead of having arbitrary rules that are intuited from just the unit 1, 2, 3. And with these three constants, you have very streamlined definition of numbers, 3 steps: natural numbers, rational numbers, and then real numbers. And it's very streamlined. It is, when you dig into what's behind it, it's the axioms of a complete ordered field, which is sort of the equivalent class of all the definition of numbers, so it points directly to it. It is also geometric, so it solves the issue of interpreting these subjective space. It becomes the shadow of this very well-structured, hypostatized subjective space. And that's really the goal of this mathematical trinity, to have a streamlined definition that points to there is a source of numbers, the equivalent class, the axioms. We don't care if it's constructed with a set. If it's useful for the theory, great. But this definition points directly to the equivalence class of all the definitions. And it points to this hypostatized subjective space, which makes it so that by definition, we conceive these numbers as navigable, as subjectively extended, not contracted to a point that nobody can see. It is already in perception, in consciousness. In a way, it has some consciousness property by having this extension. And by having this, we bridge the gap with the geometrical intuition of numbers in a real line. But we also just define it very closely to the equivalent class of all the real number definition, which is the axiom of a complete ordered field. And however you look at subjective space, even if you say everything is built logically and what remains of subjective space, or what I call navigability, is really rudimentary, or it's not, it's very at the surface level, it's sort of translated. It's not at all subjective space, but then it gets translated through some analogies. You still have the fact that this subjective space, to a certain extent, can get mapped to numbers. And so it has a rudimentary system of equivalence, of projection of the number system into subjective space. And there is always a possibility to conceive of a more structured, a more perfect subjective space that would be the source of a less perfect, of a shadow of it, into what remains for us, which is the rudimentary perception of subjective space, with all the incertitude and with all the limitations. You can always conceive of a source that is perfectly well structured, that is the hypostasis, so you can see that is a real substance behind it. You conceive of this subjective substance of perception that explains our own perception of number space, however degraded it is in our own signal, however much it is complemented by different logical system. You can still take the rudimentary process that allows us to make this mapping and say it is just one tiny window into the perfect subjective space that we define. I see a lot of potential in defining numbers in that subjective space, just because of how broad is the use of this real number line analogy, how broad is the use of this distribution of quantities in physics, how tight the real numbers as navigable and subjective space form are linked to numbers in the form of coordinate, in the form of vector space. The link is there, and so if we want to make sure that it's not just something that remains very undefined and left in the air, we have this opportunity to define a source hypostasis of the subjective space that explains perfectly then the link, however weak they would be. And I don't think they're that weak, and I think there's a lot of potential in thinking in numbers this way, and also think there's potential of simplicity in this just 0, 1 plus infinity as the carriers of the axioms of numbers, which is the equivalence of all the definition of numbers. So they become carried in 3 objects. And these 3 objects link it to the domain of this hypostatized subjective space, which is another big source of potential. And if you think about numbers in space, you can say, well, the set of real numbers itself is the thing that we hypostasize as real. The real substance is the set of real numbers. And I think you lose the fact that it generates instance, it generates elements. So your concrete reality of this set of real numbers generate elements. And these elements remain in the abstract because I think there's just computational, or there is a bug in defining an object that way, because you need to have the base elements to conform to the definition of the top, and so to have sort of a double containment, descriptive containment and topological containment. But when you have when your elements are these incountable things, you can think, well, pi is my real number, but the real number set is not defined by pi, it's defined by all the numbers that exist. So when you want to say that the true nature of numbers is just a set, I think you're missing the elements. And if you say the true nature of the real numbers is this uncountable elements, then it sort of fly out of the computable concepts. And so I think there's a lot of potential on this aspect. This is something I'd like to think even further, but I hope I have introduced this idea of this hypostasis of the subjective space and how it is the basis of this logically and geometrical source of numbers, which all the rest reflect to that in a very synthesized and 1, 2, 3 numbers are defined. Let's move on. And when you dig, it's all points to the axioms. It points to everything you need to have your numbers. And the critique of the set, I think, needs to be further clarified. I think it is clear in the sense that there's no mention of the of why it deserves to be the things to which we reduce our subjective perception of space, our coordinates. I think there's a justification missing that is in my model. But that's sort of where I am. And yeah, so I've developed several animations, and I think the result is very simple. And when you peel it, it remains really understandable. It also displays, it displays the axioms in a way that makes it visual and makes them memorable, that gives them a texture. And feel free to go through them, share any feedback if you have, and see you in the next video.